Okay, first of all, please subscribe my channel and please watch my videos online and try not to download them. In this lecture, I will state and prove a theorem about uniqueness and existence of the hermit polynomial, interpolating polynomial, and also I will give you an idea to find the hermit interpolation in a very special case that we have just some nodal point in fact x0, f of x0 and f prime of x0 and so on. So first of all, let me state the theorem about the existence and uniqueness of the hermit polynomial. The theorem can state like this: there exists a unique polynomial like Pm of degree m equal to k plus 1 times n plus 1 minus 1, such that satisfies in the following conditions. The first one is, in fact, a collection of conditions. Pk at xi will be equal to fik, which is equal to fk at xi, and this will be true for k equal to 0, 1, 2, mi minus 1, and I equal to 0, 1, 2, n. These conditions means that the kth derivative of p at each nodal point like xi is equal to the kth derivative of f at the nodal point xi. This is the condition, in fact. Now, let me try to prove for this theorem. For the proof, we start with a polynomial like px. If we consider p of x equal to a polynomial of degree m, so it will be a0, a1, x, and am x power of m. Okay, so if we consider this one and apply the constraint of hermit interpolation. What do I mean? I mean that we put x0 here and get in fact an equation with m unknown, in fact coefficients, and I put p of x0 equal to f of x0, and also p of x1 equal to f of x1, okay, and so on. Then I put p prime of x0 equal to I put x0 equal to p of x0 equal to f of x0, p prime of x0 equal to f prime of x0, and so on until p P of xk equal to f P of xi equal to f prime of fk of xi. So let me write it. It means that P of x0 should be equal to f of x0, P prime of x0 equal to f prime of x0, and so on. Pk of x0 equal to fk of x0. Okay? And I, in fact, do again something like this for x1, then for x2, then for x3, until xn. Okay? And in fact, I repeat all of this. Finally, from this equation, I get a system of equation. With m unknown and in fact m plus 1 unknown and m plus 1 equations. Okay? If we show the coefficient matrix of this system as A, then it's enough to show that AX equal to B has a unique solution. Okay? It's enough we show that this is true. Now, for the existence of the solution of this system of equation, it's enough we show that A is invertible. Okay? So, for existence of solution, it is enough to show that A is invertible. Okay? If we show that A is invertible, then it's okay. Now, note that if we put U equal to AI, or maybe it's better I show it as a vector, AI for I equal to 1 to M, and B equal to F I K for I equal to 0 to M. For invertible A, if we want to show F A is invertible, okay, note that, okay, let me write this, in fact, relation as star. Okay, note this star means that P of X has a 0 of degree at least mi. Okay? Okay. This, in fact, by this constraint, okay? If we consider p of x like this, we can get that, we can note that p has at least one zero of degree mi. Let me call it xi, okay? So let me write here, note that by star, okay, p of x has a zero, we call it xi, okay, of degree of in fact order, in fact not degree, of order at least mi. So p of x is divisible on q of x equal to pi I equal to 0 to n x minus xi to power of mi. Okay? Now, note that degree of q of x is equal to, note here, look at here, this is a multiplication of n parentheses of degree mi. So the final the degree of x will be m0 plus m1 plus m2 to mn. So I can write it m0, m1 to mn. Okay? So p of x is of degree m0 plus m1 to mn minus 1. The degree of p is 1 less than the degree of q. Okay? So if p of x be equal to 0, it is possible that this degree happen. Okay? Which means that the solution of system ax equal to b is 0. Okay? So a is invertible by a theorem in linear algebra. So AU equal to B has a solution. A unique solution. Okay? And here the proof of the existence and uniqueness of the, in fact, hermit polynomial is finished. In the continuation of the lecture, I want to show you a theorem that in this theorem, in fact, I mentioned that how can we find the hermit interpolation in a very special case. Let me stop this lecture here and please keep in touch with my channel to watch the next lecture about this theorem. Thank you, and please watch online.